And just a couple of housekeeping things. If you have any questions that come up during the presentation, we do have the chat feature that is on the right side. So feel free to enter any questions that you have. We have a group of faculty and students here. So please, any questions that you have for them, include those in the chat. I will answer any questions that I can answer, and I'll kind of go over who I am and what role I play in the department. And at the end, we will definitely save those questions for the students and faculty and make sure they're covered at the end. So I just wanted to say welcome to today's webinar. We're going to be talking about mechanical engineering at RPI. And we can go ahead and move on to the next slide so we can talk about who's here today. And we just want to say congratulations on your acceptance to RPI. We know that you have some big decisions coming up if you haven't decided on where you're going to spend the next 4 years. So we're hoping today we can answer those questions for you, kind of talk to you a little bit about what mechanical engineering is like at RPI, so that it can help you make your decision. And hopefully you visited our campus, but if you haven't yet, please, we encourage you to do that. We would love to hear from you in mechanical and show you around as well. So yeah, so today, so that's me in the first picture. My name is Kate Stockton. I'm a Senior Student Services Administrator for the Maine Department. So when we mention Maine, Maine stands for Mechanical, Aerospace, and Nuclear Engineering. So our department covers all of those disciplines. And then we also have Professor Diana Borka-Tashik, who is a professor here, and she's going to be doing a majority of the slides about mechanical engineering. We also have Professor Franck Dejoux, who is an assistant professor here. He will also be presenting. And then we have Professor Semi Aiken, who is an assistant professor here as well. And at the end, we will more formally introduce all of our students that are joining us, but we do have 5 students who are involved in a variety of different activities on campus, and some of them have different dual majors associated with also with mechanical. So today we're hoping to answer the question that most of you are probably here for: why should I choose Maine at RPI? So we're going to cover our innovative curriculum. We're going to hear from some of our world-renowned faculty. They'll also talk about some of our other faculty that are part of the mechanical and Maine department. We'll also talk about how our classes and curriculum are collaborative, and then we'll also talk about the successes that our students have and what our alumni are working on.
All right. Can I take over from here,
Sure.
Kate? Yeah, thank you for the introduction. So my name is Diana Borka-Tashik. I'm a professor here in the Mechanical Engineering Department, and together with my colleagues and our students, we'll try to keep it short and give you a brief overview of our program. I guess most of you know what mechanical engineering is about. It applies engineering, physics, and material science principles to the design, analysis, and manufacturing of mechanical systems. So that's the general description or definition of mechanical engineering. And I think you made a great choice in selecting mechanical engineering because it's a very broad engineering area, and it covers multiple, or at least in our department, we cover multiple areas of mechanical engineering, including heat transfer and thermodynamics, dynamics and control, manufacturing mechanics, fluid mechanics and tribology, as well as scientific computation. And pretty much all these areas are represented in our required curriculum as well as elective curriculum. So as a student here, you get exposed and you learn about all these areas of mechanical engineering. And as you move on to your junior, senior years, you may choose to get more in-depth knowledge in one of these areas through your elective courses. But all required courses cover pretty much every area listed here. We have multiple professors working in each of these areas. In red here are the name of all of us who are presenting today. I represent heat transfer and thermodynamics. area of mechanical engineering. Frank, my colleague, Frank Jamu, he's going to represent dynamics and control area. And my colleague, Sami Akin, he's going to talk about manufacturing area. However, we have several other colleagues in each of this area, and pretty much all of us bring a little bit of our research into the classroom, and all of us here, we work directly with undergraduate students as part of our research projects. That's something very common at RPI. Pick up any of these professors and they have at least a handful of students in their graduate research involved semester, every semester. So I'll briefly mention a bit about each area of mechanical engineering. So mechanics, we cover that in 2 courses, 2 required courses, and there are other more elective courses which cover the subject. Mechanics is important to pretty much every object, every item we design. We have to think about mechanical properties. What is the bending? What is the twisting? What kind of pressure can we stand? What is the force that can be applied? And it covers from, infrastructure, buildings, vehicles, planes, or medical devices. Another area of mechanical engineering, it's fluid mechanics and tribology. Tribology, it's essentially the science of friction, lubrication, and wear between moving surfaces, such as oil between moving surfaces as shown in this picture. Fluid mechanics, it's an area which, again, it's applicable to a large variety of applications, from power generation, as shown here, wind power generation, transportation. Also, fluid mechanics is important to hydraulics, which is a pressurized fluid that transmits power and force, as well as in medical field. So our faculty, they do research in all these areas, and of course our required courses cover fluid mechanics, and some of the elective covers tribology. Then we have the area of heat transfer and thermodynamics, which is my area. Heat transfer is thermodynamics, but especially heat transfer is important to a large variety of applications, from energy system, large-scale power production, to transportation, as you can see in these pictures, to manufacturing processes, more conventional manufacturing, or new methods such as plasma-based manufacturing, as well as medical field, cryogenic preservation or cryogenic surgery and ablation. They all require knowledge of heat transfer and or thermodynamics. So this area, this type of knowledge is covered in our required courses, as well as more in-depth in our elective courses. I'll just talk a little bit briefly about my research. I do the majority of my work is in heat transfer. I'm also covering non-traditional application. I mean, non-traditional to mechanical engineering. I use heat transfer for improving electrosurgery, which is important because understanding the heat transfer in electrosurgery helps, saving lives. Or I'm applying heat transfer for developing new methods of cancer treatment using magnetic nanoparticles, heating these nanoparticles, or developing systems for harvesting solar power that can be employed as building envelope. And in all my projects, I heavily employ undergraduate students, and many of my undergraduate students have been co-author of research papers because they are very excited and enthusiastic, and often end up staying more than 1 semester and doing research in my lab more than 1 semester. And sometimes they continue in being a master student or graduate students. So now I'm going to let my colleague Frank take over and talk a little bit about dynamics and controls.
Yeah, thank you, Diana. And hi, everyone. It's really great to see a number of new potential members to our amazing community here at RPI. My name is Frank Jammu, and I'm actually new faculty member and PI in the mechanical engineering department. My area of expertise is in dynamics, control, and autonomy. And here in the department, we are really fortunate to have like a very strong curriculum and faculty with strong research in this area. So whether you are looking at mechanical systems, aerospace vehicles, robotics, or even energy systems, understanding how things move and how to make them move more like in a smart way or in an intelligent way is critical. And dynamics and control are the backbone of modern engineering. So they enable everything from space flight and self-driving cars to surgical robots and clean energy systems. And our department here offers a rigorous yet flexible path through all of these topics with a lot of courses and projects that connect theory directly with real-world application. Next. And can you do another next, please? So, like I mentioned earlier, I am the PI of the Extreme Autonomy Laboratory in the department. And my goal today is to show you one example of the exciting and groundbreaking research happening on campus. And in my lab, for example, we are focusing on pushing the limits of what autonomous systems can do. We want to develop control systems that work in extreme, rare, and safety critical scenarios. Typically, scenarios where failure is not an option, and traditional approaches or traditional way of dealing in those scenarios may just break down. Let me just show you what I mean exactly with some videos and application of our work. So in this first example that Diana is going to play, what you are seeing right now is an aircraft in simulation that encounters like an engine failure. And in this kind of setting, there is a need for smart control system to somehow learn on the fly how to regain certain degree of control and avoid ground collision despite the failure. And we show that this can be done again in such a high stake, extreme, and unexpected situation. Next. The next set of examples are probably more concrete for you all, and they involve developing new systems to improve driving safety and to improve driving safety by understanding the limits of vehicle agility and flexibility and exploring that understanding of how far you can push the car to create new autonomous systems that can keep you safe in emergency situations like obstacle avoidance or whenever, for example, you are like skidding on snow and you still need to keep control of your vehicle and more. So the first video is going to actually involve a Toyota Supra. So this is like a drift spec car that we have modified to do self-driving, but more importantly, that we have modified to do aggressive drifting. So can you play the first video, please?
Yeah. You should disclose that you took this video on a Toyota Research Institute ground, right?
Yeah. So when I was working at Toyota Research in California, we made these experiments, and you can see I'm sitting. Oh, the sound is not working, but that's fine. I'm sitting there monitoring the whole situation. Can you play the next video? So the next video is actually doing the same thing, but on on your everyday car. So this is like actually a Lexus. So you can go to your nearest dealership and then you can buy this car. And then we just have to like hack a little bit some of the things and then be able to do this kind of like very aggressive maneuvers autonomously. And if you want to have even more fun, you can actually do even worse. You can actually take a car, put it um in rainy conditions, so like we very like low friction under the rain, and then use these algorithm and then show that you can still keep control of the car. I don't know if the next video is working. So this is actually an experiment that we did in Japan. And we put like water on the ground, and then you can see the car just self-driving around, or more like self-drifting around on the track despite the low friction surface. Next. Oh, I guess you have to go back a little bit. So right now, actually on campus, in my lab, I have like what 3 or 4 undergraduate research doing work on autonomous driving, and we actually bought these side by sides. This is like an all-terrain vehicle that we have in the lab, and in the next few years working on this, we are really looking forward to get like passionate and students who like really love to do some theory and then apply, put it on some real world application. And this is going to be one example of project that could be used as a UIP university research project on campus.
Thank you, Frank. So moving on, shifting the area from dynamics and control to manufacturing, I'll invite Semih to discuss, my colleague.
Sure. So hello everyone. First of all, congratulations for your admission to RPI, which is great. So I believe that you will be in a very trustable hand here. So let's shortly talk about the manufacturing. So, in human history, we have several industrial revolutions, right? The first one was the invention of steam engine, right? The second was the invention of mass scale production, particularly by Henry Ford, right, with his Model T car. And the third one is the mid 20th century, which was the automation, right? So we had the automation with the computers, and then it's made the process more effective, right? But now we are in the fourth industrial revolution, so which means we have a digitalized world, right? So our machines are connected to internet, right? They can stream the data, right? We live in the internet of the things, AI, and also the additive manufacturing and micro nano manufacturing. They all advance these fields. Okay. So the first thing first, as an engineer, our task is to design. Okay, so we do design to improve the society, right? But in most of the case, at the end of the day, you should manufacture and produce your design, right? So the field of manufacturing here comes into play. So you should know if your design is manufacturable or not, or you should also know which material you will use and which manufacturing process is the best in terms of the efficiency, scalability, and the cost, right? So the manufacturing science considers all these things and then to improve the society. So actually, to me, the manufacturing it's in golden age. Why? Because our machines are connected to internet, right? And then we generate too much data. And now in this era, we have the capability to process this data with very high computational power, right? So then in the near future, you will see that we will be able to print the such, the organs and the foods, right? And the some, the very the outstanding things, and the additive manufacturing will be a big part of that. So can we go to the next slide? So here at RPI, my research focuses on the surface engineering and manufacturing innovation. So, any bulk material, they interact with surrounding through the surfaces, right? So if we functionalize their surface, we can make functional parts, and they can be used in such applications, right? So to do so, what I do the fundamental science in surface engineering. So Diana, I wonder if you can play all these 3 videos. Yeah, you can also click 2 more time and they can play. Yeah. Okay, so at the left, you know, the top side, you see there's a simulation, a particle comes and hit the substrate, right? This, we actually investigate how these surfaces are created, right, within a process. And also on the right top panel, so you see there is a very generic flexible polymer material, which is PET, which is the same material with your the soda bottle. Okay, so using some manufacturing processes, we can convert this recyclable material into some electronics, right? And these electronics can actually still functional under very harsh deformation, right? So it is actually good for recyclable electronics, right? And the left bottom side, you see an example of metal additive manufacturing. So what happens here, there are 2 robots, they interact with each other. The right-hand side robot, it comes and do metal additive manufacturing using wire arc. And the left-hand robot arm comes and there's a thermal camera on it. It scans and informs the other robot for the process correction. Okay. So at the right below, you know, I mentioned that when we do all these processes, there are sensors in all these machines and this equipment, right? Then we generate the data. And I mentioned earlier, so we need to utilize this data as well. So how we can do this? We, you know, deploy the AI, the artificial intelligence, right? So we process this data to predict what will happen in the next step, or we can even predict some anomaly in the process. Also, we can use this data for predictive maintenance, right? So, you know, taken all together, so these are very cutting edge fields in the manufacturing, especially additive manufacturing and data-driven manufacturing. So they can both, you know, they're called as a smart manufacturing. Okay, so you can make the manufacturing smart. Your devices can be connected to internet. You can process this data for, you know, the manufacturing decision making. Okay. So yeah, I will be happy to answer your question later on. Okay, thank you.
Thank you, Sami. So going back to our curriculum, I just wanted to mention briefly that the first 2 years is typical, you know, more general education, and in junior and senior year, then we go to more specialized courses. To these courses covering more in-depth mechanical engineering areas. And again, we have required and elective courses. In elective courses, you can gain more knowledge in a particular specialization you're interested in. Many of our students are using their free electives for double majors, or I'm sorry, for dual majors, as well as for minors. I want to also go back and highlight our curriculum integrated with a lot of hands-on opportunities, not only in research labs, but also in our teaching labs. We have teaching labs covering mechanics, covering thermal and fluids, covering dynamics and control, covering manufacturing. Actually, Sami is very involved with one of the manufacturing lab. Sami, if you are
Sure.
want to discuss briefly?
Definitely, yes. I'm a part of teaching a class called Manufacturing Process Systems. So this course is offered for junior and senior students. This is industry-sponsored course. Okay, so the Lockheed Martin, Boeing, Sikorsky, ASML, and the other companies, they sponsor this course. And then all the students, they are exposed to very hands-on experience for the many manufacturing processes, which involves plastic injection, the CNC machining, laser machining, and the scope of this course, the students design their molds, die, they fabricate them, and then it consists of 2 semesters. One semester you are given a budget, and then you are expected to do a proof of the concept. Second year you have a certain budget, and then you need to produce 300 of this product, which is kind of the mass production simulation in the undergrad level course, which is great. I mean, to be honest, I never saw such a course in other universities. And here, when you come and take this course, I to confirm that you will have a unique experience. And I would say RPI is doing great job with this course.
Thank you, Samit. So, and learning doesn't always happen just inside the classroom. For our students, it happens outside the classroom. Many of our students, I would say the majorities, are involved with clubs, such as Engineering for a Sustainable World, Rensselaer Motorsport, or Hybrid Formula Car. And as you find out from some of our great students who are here today in the webinars, yes, our students, they do go to competition. Actually, we just won a handful of this competition this spring. And I think I'm gonna get back to Kate. And now, Kate?
Yeah, thank you. Yep. So just to cover what kind of support our students get in the main department, all engineering students will be assigned a first-year hub advisor. So those are my colleagues that work upstairs. They have a smaller advisor to student ratio, and they work very closely with those freshmen to really ease them into not only life as an RPI student, but life as an RPI School of Engineering student, and they help check in with them and make sure they're all set with their courses, and help them connect them to any resources that they might need that first year. In the sophomore year, students are assigned to a faculty advisor that is part of their major. And then they also can use my office, which is the main undergraduate student services office. So you kind of have the best of both worlds. You have a professional staff advisor as well as a faculty advisor. So, and we can support the students in different ways, but also in many of the same ways as well. Students also have access to ALAC tutoring. This is what you typically know about, course tutoring. A lot of courses automatically set up tutoring for throughout the semester. But there's also the ability, if one of your specialized courses does not have a preset time for tutoring, you can reach out to ALAC and they will find a tutor for you based on what your needs are. We also have the Learning Assistance Program. This is similar to what you think of as like a residence assistant, so an RA in a dorm, but this is somebody who lives in your dorm and also supports students for their learning needs, not just for, social and residential needs. Although we do have RAs as well. And we do have something, we have a class dean system. So all of the classes, all first year students go through first year experience, and that is a specific, excuse me, a specific set of people that help with just the first year. And then after that, similar to how you get assigned an advisor through your major, you also get assigned a class dean that will stay with you until you graduate. So that's somebody who takes you on as a sophomore, and then they are your class dean for junior and senior year. And then we have an early warning system. So anytime a faculty has a concern about a student, or a student's grades are slipping or anything like that, they can submit an early warning, and it goes to an intervention team, and we just check in with students and make sure that the student is being supported in any way that they need to have that support. And then we definitely have our Center for Career and Professional Development, which plays an integral part of our students' experiences, because all students have to graduate meeting 2 graduation requirements through our ARCH program. So if you haven't heard about ARCH, basically it is a way that our students are required to have an outside experience before they graduate. And then one of those requirements is that they have to take a class. It's a 0 credit class, but your grade is either satisfactory or unsatisfactory. But that class, the purpose of it is to introduce students to the supports that the Career Center provides to help them make sure that they're prepared to be, searching for internships if that's what they want, or research opportunities, volunteer work, whatever they're planning to do for that away experience that students need to do. So yes, lots of support here on campus and specifically within the main department. Yep. And then I have a link to provide some more information that I'm going to put in the chat. We always get a lot of questions about where do our students go to work afterwards? Where are our students hired for internships, co-ops, and employment after they graduate? Where do they go to grad school? So this is really just a short snippet of where our students go after graduation. But in the link, it provides a more thorough list of employers for specifically you can find for mechanical, but it does list it by major. And then from last year, the average reported salary for our entry-level students was $77,865, and then the average reported co-op salaries for juniors was $21,665, and for seniors was $24,002. So we do report that every year. Like I said, if you need more information on that, I'm also going to put a link to our Career Center. Then you can find even more information about salary statistics and job hiring statistics.
So I just saw Rivian here, and I want to mention that Rivian CEO and founder RJ Scaringe, he's an RPI grad. He graduated from our department, mechanical engineering, and actually he was a student in my early days here. And he's coming from for commencement to give a talk for commencement.
Definitely. Yeah. Thank you. Yeah. So now we're going to kind of pass it off to our students. So students, as we get to your slide, just introduce yourself, cover, what's on your slide. And then for the students joining us, if there's anything that you want to ask any of the students about, hopefully this will intrigue some questions. The questions are coming in, so we'll start answering those as soon as our RPI students have a chance to introduce themselves. So we'll start with Megan.
Hi, I'm Megan Lynn. I'm pursuing a major in mechanical engineering, as well as pursuing a minor in sustainability studies. I'm from Fresh Meadow, Queens, here in New York, and a couple of the clubs I'm in currently is Women's Mentoring Club and Ski and Snowboard Club, as well as Hong Kong Student Association and Residential Hall Association.
Thank you, Megan. Grace.
Hi, I'm Grace. I am from Maple Ridge, British Columbia. I am Canadian. I'm the current chassis suspension tires lead with Rensselaer Motorsport. I also do research with Professor Mishra and Professor Franck. I work on the Can-Am that he showed in one of his prior slides. And I'm also a member of Maine's Student Advisory Committee.
Thank you, Grace. Sierra.
Hi, I'm Sierra. I'm from Cary, North Carolina. I'm a dual mechanical engineering and design innovations and society major. I'm also a part of the varsity women's soccer team here and an ALAC tutor as well. I'll be pursuing my master's in mechanical engineering next year, so finishing up my undergrad now. And I've been interning with Affiliated Engineers, which is a MEP company, for the past couple of summers and been doing construction work. So.
Thank you, Sierra. Hannah.
Hi, my name is Hannah. I am in my third year of mechanical engineering here at RPI, and I am doing a minor in studio arts. I'm from California, and some of the things that I do on campus, I'm a lab assistant for the engineering processes class, which is a class where you get a lot of hands-on manufacturing experience. I'm also a research assistant with the School of Architecture's Additive Manufacturing program, and then I am also helping restart the RPI section, student section of the American Society of Mechanical Engineers, Society of Women in Engineering, Ground Zero Basement, which is like an arts and music club, and yeah.
Thank you, Hannah. Jaden? Jaden, we can't hear you if you're talking.
I don't think Jaden made it yet.
Oh, okay.
So, let's see. So yeah, if you guys have any questions for any of our students or faculty, please add them in. We had a couple that were addressed, but we did have some questions about the car clubs, and I know that Grace had answered those. So if you're interested, definitely take a look in the chat. And then maybe we can have Grace talk a little bit about the Rensselaer Motorsports. Is always something interesting to talk about. Grace, you want to talk about that a little bit?
Sure. So with Rensselaer Motorsport, we are a Formula SAE electric car club. I've seen someone asking about possibly Baja teams and other car clubs here. We are the biggest car club on campus. The second biggest is RSAS, which is Rensselaer Student Repair Shop. So it's kind of like a auto shop, rent a bay, rent a space, and you can work on your car for as long as the shop is open and until you're done with the at least your car. And we, at least for Rensselaer Motorsport, build a new car every year from scratch. We basically look at the new rules for the year, design a car, and then using all of the resources we have, such as school supported funding sources, manufacturing facilities, as well as sponsors, to get something built and running every year, and we take it to Michigan to compete.
Thank you. Oh, it looks like we have a follow-up question to that. So what do the competitions look like? Is it just based on the race, or do they also focus on design? That's a really good one.
It's a hybrid competition where you have about 50% of it is business and design related. The other 50% are what we call dynamic events. So we have static and dynamic events. We do cost reports, we do business reports, and we also do a design report briefing. And then the dynamic events are not quite your typical car races, but it's closer to autocross. So we start with what is a straight line test, a drag race kind of thing. Then we do skip pad, which is a figure of 8 steady state cornering, kind of testing how fast can your car turn. And then we do autocross, which is one lap, really fast, kind of qualifying format race. And then we do endurance, which is drive your car for about 20 minutes straight and try and finish an endurance course.
Great. I see a great question. It'll give our chance for all of our students to kind of give some input, but could some of the students talk about an average day as a mechanical engineering major? Hannah, you're first on my screen. Do you want to get us started?
Yeah, sure. It's so hard to think of like the average day just because there's a lot of variety in my like day to day, and that's the way that I like it. It isn't like that for everybody, but I know for me, I like to have a lot of different things going on at once and get completely into something one day and then focus on something else the next. So just thinking about like what I did today, I woke up early and I went to a dynamics class, and after that, I went down to the processes lab to follow up about a project that I was working on for somebody else, and talked to some faculty members that I like about some of the work that they were doing when I came in. And then, I have a little time. I really like the campus. It's just there's a lot of little pockets that are great for like studying and really nice atmospheres. My favorite is the library in the architecture building. So I went up there and studied for a little bit before going to a lecture class I have that is very difficult. So right after that class, I went to office hours to get help on that from some TAs, and then I came here. So usually my day kind of follows that sort of schedule in terms of like combination of going to classes, doing my own projects, and then talking to TAs and faculty.
All right, Sierra, do you want to go next? And you have a sport that you're also working into that day too, so that might answer another question on how difficult it is to manage a sport with being an engineering major.
Yeah, I saw that question roll in. Yeah, so it kind of depends on whether you're in season or not. I know the question that got asked in the chat was specifically asking about uh in indoor track and outdoor track. Um, it's definitely you kind of got to learn how to manage your time. I would say it's uh, teaches you a lot of time management skills. That being said, there's RPI athletic communities very close with each other, and there's a lot of resources within that community if you're ever struggling with the class, especially with the mechanical department being as big as it is. There's a bunch of other athletes probably within your team, especially with the running teams being so large, that have also taken those courses that have old notes or like old practice exams that you can work on to study for a test. Um, Beyond that, kind of depends on what point in the year you're in. So when I'm in season, I play soccer, so it's in the fall. We typically have a couple days of lift as well as practice pretty much every day, and games and competitions and things worked into that. Um, but most professors are pretty understanding of trying to work around your schedule as long as you communicate with them early on. They're uh, very accommodating, which has been nice. But yeah, usually go to classes, Monday and the way our lectures work, it's Monday, Thursday, and Tuesday, Fridays are the lecture days, and then Wednesdays are typically lab days. So depending on whether or not you're taking a bunch of labs that semester, you'll either have a lighter day on Wednesday with not a lot of classes, or sometimes if you're taking a bunch of labs in that semester, you're going to be on campus for most of Wednesdays. But yeah, just going to class, doing homework afterwards, and then going to practice depending on what time it is.
Megan, anything you want to add or talk about your typical day? Not that there is one.
For me, a typical day, I mean, every day of the week is kind of different for me. Um, Depending on my like class load, I'll head to the library, just study a bit, and then head to another class, and then I'll usually meet up with my friends afterwards, and we'll either just study in the union or we'll like go grab something to eat usually. And then depending on if I have a club meeting afterwards, I'll go to that.
Great. Grace, anything you want to add?
Not really. I'm away right now, so I can't really talk about my day. It's just going from one research meeting to another research meeting to doing another research thing. But when I was taking classes last semester, I like to get my classes out of the way early on in the day, so I'm probably at 6 a.m. in an office space trying to work some stuff, go to my first class at 8, get through all of my classes, and then go into various labs and do stuff. And then meetings are always at the end of the day. Go to the meetings, maybe get pizza if it's Professor Mishra's meetings, and then go to motorsports shop and get the car done as much as I can before going back to my dorm.
Great. Yeah. So there was some questions about robotics. I was hoping that Jaden would have joined, but because I know he's part of that club, but I know that Hannah had answered a little bit. Looks like she's new to the club. And then there were some questions more about the combustion REM group. We don't have anyone from that group on here. So if anybody has questions about that, you can just follow up with an email to me and I'll try and connect you with somebody. I'll put my email in the chat as well. Anybody want to talk about how much homework they get or how much sleep they get?
Or maybe about socializing, because it sounds like it's only work, 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 but I have a daughter in this program, and I know she has fun too. So I think what makes RPA so special is because it's not part of a larger city. So all fun activities happen on campus, and there's a lot of bonding between students. And this friendship, they last a lifetime. They're very close friendship. That's my understanding.
I can take this question. I think that there's a wide variety of different people again that you're going to meet on campus, and it kind of depends on what sort of person you are. I know that I really prioritize sleeping and making sure I'm well rested and making sure that I am hanging out with my friends, and I think it just comes down to time management. It's definitely not impossible or as impossible as a lot of people might paint it out to be, and it's going to be like that in any kind of hardcore program like engineering, where I feel like I do like hang out with friends at least like once or twice a week. I sleep like, for me, I think like 8 to 10 hours, and I think that's kind of average. And there's definitely going to be nights when you have a big project due or a big report, and there's going to be exceptions to that. But I think it really just comes down to what kind of person you are and time management. And to speak more on socialization, also, like, even though there is so much great stuff happening on campus, there's a lot of Troy is like a really interesting town. There's a lot of fun things happening. I think that I'm pretty active off campus as well. There's the local music scene is really great if you're interested in that. And then I'm also involved with the Arts Center downtown, which has a lot of they offer classes which are really nice to kind of supplement engineering classes as well. So
That's cool. Thank you, Hannah.
So I know nobody asked this question, but I thought it might be interesting, Sierra, if you wouldn't mind talking a little bit about your dual major, because a lot of people probably haven't heard of design, innovation, and society and mechanical as a dual. Maybe you could talk a little bit about some of those classes that you've taken.
Yeah, definitely. It's definitely a bit of a smaller dual major and a bit of a smaller department. But Science Innovation Society, it's within the Humanities and Arts School, so it's within the Haas department. But it basically takes a focus on a lot of product design and design theory. So throughout that course, you go through and you have multiple design studios. So I want to say you take a total of I think 5 or 6 design studios, and those are gonna make up the majority of the design portion of your dual major. And in those studios, you typically will have projects, it's very project-based, and, you'll either be given a problem or you'll explore a problem that you care about, and you will go through the whole process of what it looks like to design for that user, and then going through the prototyping and, kind of the reflection process of like what decisions were made and things like that. So you get a lot of hands-on work with 3D printing. The Haas department has a makerspace in the downstairs of Sage with a bunch of 3D printers that are available, as well as some resin printers. There's also a wood shop down there that Abe, one of our professors, runs. So he does metalworking as well and is really good to be able to help out with that. And then I've also utilized the Forge, which is a student-run makerspace on campus. So that's been super helpful, especially this semester with a bunch of my design classes. It's doing a lot of prototyping, 3D printing. But along with that, you'll take some sustainability courses. Department, I would say there's a very heavy focus on accessibility and universal design. So making sure that everyone can use what you're designing, and a lot of focus on that. So it's a little bit of a break from some of the straight technical pieces of engineering, which I personally enjoyed. So some writing too and things like that. So.
Thank you. And I know one of the nicest things at RPI is that we can get our undergraduates involved in research really early on. And I know we've got faculty that take on research students, and we've got some students here who are doing research. So does anybody want to jump in and talk about any of those experiences?
Yeah, I mean, I guess I can say something. So this semester typically spring semester, I have two students. Grace is one of them, that are doing their arc semester away in the lab. And I have two or three more undergraduate researcher that are doing UIP for credit in the lab. So and the project, because the project involves a lot of different skills. I have students from the ECSE, students from the making department that works together on essentially making that platform do what we want it to do.
Yeah, as I mentioned, it's very common to have undergraduate students helping around in the lab. They usually take this task as actually they do research for credit. A lot of our students, they do research for credit. They use this credit as a technical elective instead of a technical elective. And some students, they do get paid. I think this is more common during summer. But yeah, so some students are hired as undergraduate research assistants during summer. It's equivalent to an internship.
And I also have two more undergraduate researchers that are working with me over the summer. As yeah, just to say that we actually, depending on on the advisor typically or the professor, some people are actually looking for undergraduate researcher doing some research on campus over the summer. Yes.
Yes, yes. I do have three undergrad researchers in my lab currently, but over the summer we will have several for ongoing projects. So yeah, they're doing great.
Yeah, in my case, I have numerous undergraduate students who are co-author on journal publication. They've been there for more than a semester. They've been engaged. They produce useful data. They learn a lot. They often talk about their experience, research experience during their interviews for internship or full-time job. So we encourage all our students to get some hands-on experience, right? It's very important for us to have students who actually, know how to do stuff in practice, not only on paper, but in practice. And this is something that we encourage throughout the curriculum, because that's one way to learn how to learn. It's not necessarily very important what packet of knowledge you gain while at RPI, but it's what is really important, and what we really emphasize here is how to learn and developing critical thinking skills, because things evolve. You go out in the industry, things change at an increasingly fast pace, and you have to learn outside the school. You have to learn in unstructured environment. And in our curriculum, we offer you these opportunities through our projects, class projects, or projects as part of ID, Introduction to Engineering Design, and Capstone. I think we have more question about dual majors, right? And that's important because we have a very common dual major in our department, and that is between aeronautical or aerospace and mechanical engineering. In fact, the large majority of our aerospace aeronautical students, they have a dual major with mechanical engineering.
Yeah, Grace is an aeromech.
We're currently at 6:55, so just wanted folks to know that we have about 5 minutes left. Any last questions that we might be able to answer before we wrap up?
I did see a question above that we didn't get to yet. I think, let me see if I could find it. It had to do with your first year. I'm trying to scroll through. I think that, shoot, I'm not finding it now. But basically, like, what was the most welcoming during your first year? Like, how did you get kind of connected with the college in your first year? Maybe you guys can talk a little bit about that.
So for me, I was part of the women's mentoring program as a mentee. So I came in, and that program really helps you transition into the school, and they provide really good assistance with it as well. So my transition, my first year, my transition to the school was pretty welcoming. I actually transitioned pretty well because of that program. So it's great.
And there is a question for our out-of-state students, which I think all of the students joining us today, except for Megan, are from out of state and even out of the country. So how did you end up choosing RPI? That was one of the questions. Wants to start? Maybe let's have Hannah. You want to start that? You're from California, right?
Yeah, you know, honestly, I lived in California my whole life and I was kind of like I want to just get as far away as possible and experience something new. I think like everybody else has been saying, besides just like classroom experience, college as a whole is all about, for me, getting as much new experience as possible. So, being in New York has been really nice. And, um, you know, I did apply to some schools that were in California, and I was a little bit scared, obviously, committing to RPI, but for me, I'm really glad I did. It worked out. I like that the weather is different. Everything's like, it has this like whimsical element to it because it's new to me. So I really enjoy it.
All right, Grace, you're from out of the country. You want to talk about how you chose RPI?
Yeah, to be completely honest, I had a change in major at the last moment. I was applying everywhere for plasma physics, and RPI was just one that was like flexible enough to let me in without much of like a pain to switch majors last minute, and also it had a very flexible program. I was looking at possibly doing a dual with mechanical and um, physics at one point, so the flexibility was kind of what sold me on RPI.
I have a couple more questions, late questions coming in. Kate, you wanna jump on that?
Yeah, I'm getting a couple like one-on-one questions too, so I'm answering those. But I think Sarah answered one of the questions about what time classes end. That can vary, but you know, students sometimes can manage to make a schedule. That means they aren't here on Fridays, probably not very often. Yeah, I don't know if anyone has anything else to add about that. Let's see, dual major. Somebody answered that. Again, it depends on the major. So some duals work well. I know we talked about DIS, we talked about aero. So we can do aerospace and aeronautical with mechanical. That's very typical, very easy. I never say anything's easy, right? Because it's all hard classes. But in terms of the amount of credits, that's an efficient degree to finish in 4 years. And then we do have some students that are doing a dual with mechanical and nuclear. Um, once in a while, we'll get a student who does a double major. What double just means that there's at least 30 more credits after you count the first major. We sometimes have that with computer science because it's in a different school, and there's a lot of those computer science classes that are not part of our curriculum, so it does add to the time and credits that you need. But some students do manage to do that, especially if they're bringing in a lot of credits from high school. So yeah, there's a lot of different ways, and that's one of the things that you'll work on with your advisor is to try to come up with a plan. I answered an earlier question about business and mechanical. So if we have a student that has those two interests, we can really explore as many different options that work well for that student. And one of the things that I mentioned was sometimes it makes sense to do an undergraduate degree and then a different graduate degree. So we kind of present all of those options to students and see what that looks like for that particular student, because everybody's going to be a little bit different in terms of how many credits they can handle each semester, how flexible they are in terms of, you know, can they stay a little bit longer if that's what they really want. But yeah, I think I think that's it in terms of questions. Anything anybody saw that I didn't answer that you want to jump in and address? If not, I think we're good. So Grace, so an attendee had reached out to me and I was just typing it out. Basically, like, if you do want to visit, reach out to me. We can try to give you a tour of our department. Tomorrow, I know she was mentioning, sorry, this is going to everybody, but tomorrow we're having a de-stress fest in the afternoon, and I think that lines up when her son is going to be on campus. So I was just going to say, come and visit us, and you can pet some therapy dogs and make some trail mix. So yeah, thanks for attending tonight. Thank you to all our panelists, all our faculty and students. Thank you, Randy, for your support as well. And thank you to all of our accepted students for joining us. And we hope that you will come visit us, and we hope to see you in the fall. Thank you.
Thank you, everyone. Have a great evening.
Bye.
Thanks, guys. Thanks, Randy. I stopped recording.
Have a great evening.
You too.
Bye.